Imagine a world where great-great-great-grandchildren would have to live under the sea. They will have to live under the sea because us, humans, before them, would have used up all the resources so that they had to be submerged to survive. And in this water world, no electricity. So the light will be provided by jellyfish, fish, and squids. And maybe those generations will wonder why didn't we think about using those natural resources to avoid the disaster. So I invite you to open your eyes right now, look at nature, and finally dare to find unique solutions. I'm not a genius, or even an inventor, or even a scientist. I am a designer. And me and my team have decided to use the superpowers that nature has to actually grow our own light. We are developing a biological living lighting system which works without any need for infrastructure or electricity. And it might sound a bit crazy, or maybe a bit brilliant also, but I can assure you that it can change the way we consume light, but also the way we consume, in general, the resources and the limited resources that the planet has. Those fish and squids are able to produce light thanks to a phenomenon called bioluminescence. They carry some genes coding for enzymes responsible for light production. And scientists have been investigating bioluminescence since the 1970s, and have been using it for biomedical uses, for example, as a marker to diagnose genetic disease. But humans have been curious about bioluminescence for a long time. Already in the ancient times, the Roman Plinius was saying that jellyfish were glowing so much that we could use them as torches. And later, the Native Americans were using those little insects in the forest called cucuros to illuminate their houses. And they were even putting those insects on their shoes so that the snakes are living when they're hunting. And during the Second World War, the bioluminescent plankton will help planes to spot their aircraft carrier. So if we have these resources, why not use the properties of fish and squids to actually reduce the 19% of electricity used in the world to illuminate, which is responsible for 5% of the global greenhouse gas emissions? In nature, bioluminescence exists at a bacterial scale. For example, the bacteria living inside squids emit light to make the shadow of the squids disappear off the ocean floor to hide from enemies. The bacteria are alive, so as soon as they're alive, their metabolism keeps doing the chemical reaction of light production. So the energy really comes from the inside. So to grow our own light, we focus things on those bacteria. But using directly those natural bacteria will be a bit difficult for two reasons. First, as I just mentioned, bacteria and bioluminescence happens in nature linked to a biological function. So it will be a bit complicated to wait for the bacteria to need to hunt or to flirt or to hide in order to enlighten our cities. And the second reason is that those bacteria live in deep oceans, so they live in very different conditions of pressure and temperature. So bringing them back with us on Earth will be too complicated to control them. So what we do to solve that problem is that we order DNA sequences from DNA banks from those marine bacteria, and then introduce the gene into the most common, harmless, and characterized bacteria that we have in the labs. It's the bacteria that grow on your stomach, that also grow in animal stomach and in plants. And it's called E. coli. So bacteria might seem a bit weird and a bit disgusting. But do you know that you carry in and on you 100 billion bacteria, which means 10 times more than the human cells? Bacteria are really everywhere. And most of the time, they're harmless, but they're also critical for human welfare. So what we do is that we provide the bacteria the ability to make light by giving them the genes coding for bioluminescence in the marine bacteria. This is called synthetic biology. And this form of synthetic biology is not dangerous for your health and your environment as soon as it is controlled, and it can really lead to game-changing applications. At first, when we started with my team, we only were able to make few seconds of light. And then, after 1 year in the lab, we were able to have 3 days of continuous lighting. But the most exciting part is that the possibilities that offer synthetic biology are really still amazing. For example, by modifying them, we can control when it goes on and off. We can have different colors. We can make the system last so much longer by creating little ecosystems inside the system so that it's becoming more and more autosufficient. And all of that thanks to coding DNA exactly like you would code a software. So finally, what would it change if we didn't need electricity to produce light anymore in our way to do things? Well, I think it will change the whole paradigm of light. First, it will change the way we produce it, because we won't be extracting material, but we will be growing raw material from living organisms. And bacteria have an exponential growth, which means that they divide in half every 20 minutes. So we can imagine that tomorrow, you or companies will have enough infrastructure to grow their own light themselves. Then, it will change the way we buy and distribute light. We will have to think about new business models, because it has a shorter lifespan, but also because it's living organisms, so we need to take care of the end of life. So why not use renting models and subscription models? What if we could deliver you the light you need, and then when it's not working anymore, take it back, recycle it, and give you a new one? It will mean that light won't be just a product anymore, but a service. Then, it will change the way we use light, because the light itself is very different, and it's so much smoother. But moreover, because light won't be an object anymore, like a bulb, but light will be a raw material that can take any shape, it can adapt to different surfaces. And finally, it will change the way we regulate, because as you can imagine, the laws have not been sought to have a daily use of modified bacteria. So the legal system is not adapted at all to this new kind of living product. So where might we use this kind of biological lamps? Well, back in 2013, there was this law in France forbidding shop owners to light the shop windows at night because of energy consumption and night pollution concerns. So we just thought that maybe offering them a new alternative, a smarter and smoother enlightenment for their shop fronts by creating customizable bioluminescent stickers will solve the problems. But we can go so much farther. Imagine we can equip entire streets with bioluminescence. In the buildings, on the shop fronts, on the urban furniture, on signs. It will not just reduce the use for electricity for these fields, but also change the total ambience of the streets, and therefore reduce the light pollution, and maybe we will be able one day to see the stars again. And then, if the technology goes better and better, we can imagine to equip the 1.2 billion actually living in the dark, because they don't have access to electricity. And if we're able to provide light where there's no electricity because it's too complicated or too expensive, we can also use it in the countryside, on parking spots, on construction sites. So bioluminescence offers many, many alternative solutions, and it can have a real and huge impact on our lives. So yes, there is a lot of challenges ahead to make this bioluminescence an evidence around the world. From changing the mindsets to controlling the regulations, and again, concerning the infrastructure concerns. But I've been working for a few years now, identifying the right people to talk to and to work with to make this dream a reality. So maybe you and I won't have to worry about living underwater. But what about future generations? To prevent from that, I'm working with a team of 10 very young and crazy people to finally make this illumination revolution happen. Thank you.